All right, we'll do a little test. Can you folks hear me okay?
We can hear you.
Yeah, give me one moment.
And sending, you're welcome to use your camera if you want.
Okay.
But if we get over 20, like if we get a few more people, it doesn't work over 25. Yeah, we're already at 22. So you might have to turn it off unless you really want to have it on. But
No, we're good. We don't need to see my face.
I noticed you weren't in the basement, or did you turn the basement?
Oh yeah, so I mean, I'll cover it in the introduction here
Oh, you
shortly.
moved. I
Well,
forgot
actually,
you moved. The
we
whole house. I'm sorry, man. I'm a jerk. Go ahead.
actually hold on a second. Let me go ahead and share this. Give me 1 second. Okay, can you folks see that?
I can see a meandering.
Yep,
Yes.
that's it. Cool. All right, because I don't see the on my end. I apologize, folks. All right, so yeah, I guess I'll give a little bit of that. Yeah, the details of why I'm not where I used to be when I was Twitch streaming. So I recently moved, and I'm still in the process of getting this place set up. On the plus side, this is not a shared room, so this is I don't have to worry about my wife walking through when I do streams or presentations or interviews or anything like that. Yeah, I would love to get back streaming. I'm a recent dad for folks who are not familiar with me, and so part of the issue is I've got a 10-month-old, and uh, that's been it's been fun, but definitely a lot more work than I originally had thought. Kind of all consuming at this point. All right, let's see if I can get this thing started. Whoop. Nope, that is the wrong direction. Cool. All right, there we go. Yeah, then ain't nothing should be drinking drive for now. Yeah, so this talk is systems engineering and scale. So I'm going to kind of go over some details. I work for a very large cloud service provider. Some folks have already mentioned the name a few times. Um, I've worked for the federal government, for defense contractors, for small IT shops, kind of everything between. We'll kind of go through my background here in a second. But this will be a somewhat vague or general presentation. I love talking shop in specific scenarios, but I have to get approved for those in advance, even for past jobs, due to what I've worked on. So I'll love to talk about situations, but they'll probably be in it's a feature, not a bug, the vagueness, so to speak. Yep. So who am I? My name is Will Fry. I'm a senior engineer at that said cloud company. Got a few certs to my name. That's kind of how I got. That's how I met Scott at Tennis. He was doing some streams. He was doing some Linux certs, and at the time I had almost no certs to my name. I think the only thing I had was Security Plus, just because 8570 compliance required it. But I just it's one of those things. I used to hear back when I was a Unix systems administrator a few of these different cert acronyms like RHCSA, and they were held in really high regard. And so when I found Scott's Twitch stream, I was like, "Oh, this seems cool. This would be a cool time to go back to those things I've always wanted to do." It was kind of a weird position because once you get in the industry long enough, that certs really just don't hold the same weight. Either you can do it or you can't. So once I got to that spot, I just I would say I got lazy slash lost the drive to really start studying. So the current company, I've done over 110 interviews. I'm not what they call a bar raiser, but pretty close. I get pulled into a lot of what they call senior loops. So these are ones where engineers that are below the level can't do it. I'm a big Bash fanatic. The majority of what I prototype is in Bash. It's what most folks know me for. I love Go. That's what I'm kind of working on and learning. And then Python, just because the majority of our team is a pretty Python-centric team. I work with other languages. Some so basically DSPs, but also a lot of like Ruby and Java. I say work. I don't, even though I could read through it, I would not say that I know those languages. I have to know some of the basics just so that I can work with them. But the company I work with, we have probably over 20 languages in use, and the majority of the ones that I use are probably those five right there. Rust shows up, Perl, things like that. But I would say for my day-to-day work, I don't come across them very often. And then I'm primarily working in the service land. When I joined this cloud company, I worked for a very small product. You probably never heard of it. It's called Lambda. That team was we could talk about that later. My experience on a very high performing team and what that's like. You know, big companies are large. They're not all the same. So the experience I had when I first started is very different than now. Yeah, Rust mentioned King Buns. Yeah, so the agenda, we're going to go through the preamble real quick, a little bit about my background. We'll talk briefly about what systems engineering and what scale means, how to engineer scale. We'll walk through some examples and some QA. Yeah, so this is based upon my experience in the industry. I have about 15 or so years. As much as I try to be up to date and accurate and factual and unbiased, at the end of the day, some things are just like your opinion, man. And actually, I go back to yeah, as a preamble. This was kind of hectic putting this thing together. Heck kind of knows I lost my second nanny within a month, and so and my wife was out of town, so I was solo parent for the last 2 or 3 weeks, and it's been a little bit crazy. So this is not to the caliber. I know everyone was talking me up. This is not to that caliber, but nonetheless, even though this won't be as good as I was hoping to make it, hopefully you folks find use for it. And I think the biggest thing to take away is at the very end we can talk shop. And I think that's going to be useful for you to ask questions about, like, what does it mean? What specific questions, like, what does it mean when you're writing a run book for a company at scale? So hopefully this won't be a total loss for you folks. And if nothing else, there's some memes in there for you. Yeah, second enemy month might be a you problem at this point. I totally think that might be the case. Katie and I are pretty. My partner are pretty. We both have two jobs, and we both coach and stuff, and so we have a lot of requirements. So definitely could be. So my background, these are a few things that I've done, and inside of here, go ahead. We'll take a second, vote in chat for which one you think is a lie, which one I haven't done. I come from a non-traditional background. I have a degree in religious studies, which is like cultural anthropology. It's not really, it doesn't seem on the surface as something that carries over or cross transfers over to IT. But for sure, I think my experience has informed how I operate and how I work. We see some retail clerk, line cook. Okay, Linux is a religion. Yeah, Treasure. I was a slow adopter. My roommate in college was the head of the Unix and Linux club, Slug, and I just was a Windows fanatic, and I talked a bunch of crap about Linux back then, and then I've become a complete convert. So I missed on my opportunity to be part of Slug. ProLUG is definitely a better acronym. They did not have a great one. It's actually locksmith. I was not a locksmith. I do as a hobby. I do some locksmith competitions, but everything else I've done and a bunch of other things that are not listed. Basically, this is just trying to demonstrate that you don't need to come through a traditional one. Boot camps, college, internships, those are great avenues to get into the industry, and I'm not trying to knock them. And depending on how you operate and how you learn, it could be make or break. But this is a great example of, you even with that, even with making some bad choices, or sorry, let's say even with making some questionable choices in what I got my degree in and what I've done over time, I still think that it can help get you a job, otherwise known as robbery. uh, no comment. So yeah, as you can see there's a variety of positions, and strangely enough, you might on the surface say none of these things really have skills that transfer over. But what I would say is that a lot of the folks you've listened to these talks are incredibly smarter than me, much better engineers. So one of the questions that probably comes up is, Will, you're going for your staff or principal. If you're not really a great Unix admin, and you're not really a great developer or manager or project manager, like, so how are you there? Like, how did you become a senior if you don't just knock those things out. So, and that's kind of what my talk's going to be a little bit about, since systems engineering and my background kind of meld really well together. And we'll kind of talk about how that works. Yeah. All right. Cool. So I mentioned that it works out well for my background to systems engineering. So like what exactly does my day-to-day encompass? Um, I used to work as a Unix systems administrator. That was very routine sort of work. You're adding LUNs, you're figuring out what, Nick is broken or something. You're going back and finding the GBICs and replacing it. You're doing that sort of standard stuff. Our Unix shop did a little bit of everything, so we did do some hardware stuff, some rack and stack. Some shops, it's very, it's very dedicated. But ours, we kind of crossed the lines, I would say, a little bit, running, not running a whole lot of cable and whatnot, but doing some of those positions. So, but those are all pretty routine. And even though, I really enjoyed my time, that's how I kind of cut my teeth, was on the Unix shop. You do get kind of into a groove. I think Fisherman, you mentioned it. After you spend enough time there, 5 years, you you start really knowing all of the parts and processes, right? You're still learning things, but that last 5 to 10% of what you're learning, it's a significant more investment, and you don't have there's not the same push for you to learn it, because when you're first learning something within like become a systems administrator, like, hey, I need to know how to add a user add, I need to figure out what's opening a file. I use LSOF, those sort of things that push you in that direction. I need to learn strace because I need to figure out what the hell this thing's doing. You start losing that sort of pressure as you go longer and longer at a job in a shop, especially at a small shop where you don't end up touching a lot of technologies, right? These government places tend to be very steeped in whatever they are. So we had old Solaris systems. I was a Solaris Unix admin, did some RHEL and some SUSE as well. But whatever those things are that you have, you tend to work on them, know them well, and they don't tend to change very often, even when they're end of life. Um, so it tends to lend itself to, you get in the role, you come up to speed with Unix or Linux, you learn some of the core commands and stuff, you build that skill set, but there's nothing really pushing you to learn, say, at the time, there wasn't really Kubernetes, but there's nothing pushing you to learn like better container technologies. So I don't know if you folks are aware, but Solaris had some old container technology called zones and CDOMs and LDOMs. Really cool stuff, obviously ahead of its time. It never really caught on, but now Docker and Kubernetes and Lambda are just kind of the ubiquitous. So there are some really cool things that some of those old Unix distros did, or that I think that they did, like ZFS that came out of it. But for the most part, you're not really playing with that stuff. You're not really doing it. So when I moved over to this cloud provider, I got an invite that said, hey, you've got this serverless team. They're looking for a systems engineer. I didn't know anything what a systems engineer meant. I was trying to place that in the context of like systems administration or the government, where like there's network administrators, there are systems administrators. I kind of had heard about DevOps, but I didn't really understand like what this is. And so when I got the job, I was kind of just like, I would say, overwhelmed. At the government, we don't have source revision control. It's like you make a copy of a file, dot back, and you call it a day. Like that is your source control. Maybe you have an NFS share or Samba where you're like storing some of these scripts or backups. But it's pretty, I would say, pretty old school for that sort of stuff. Yeah, dot back, not dot rig. Hey, man, that was a fight among people up there. Everyone has their own style of doing things, and some people feel very strongly that you want to use dot bak, and others, dot org. Some funny stuff. But yeah, so that's why did I take the job? It was kind of outside my scope, and I wasn't really sure what it was. Well, they talked about the things that I would learn because I didn't have any understanding of like what serverless meant. There's going to be a huge pay increase. Honestly, that was a big demarcator. Change of pace, but going back to that fact that I had worked as a Unix systems administrator for a long time, and it was getting to the point where I kind of knew all of the players and knew the space, and I wasn't feeling very challenged. Linux was a key technology, and I was going to steep myself a lot more into it, along with some of those newer tech, like micro VMs, container technologies, and that sounded exciting at the time. But I'd still have one foot back in what I knew, which was Linux. And then the sort of why not? It's it's a chance to do something else. And also it's the role that they were hiring for. So that's the key. There's a funny story about that, King Buns. Someone created a script to try and do that, but they didn't handle the existing dot back situation. So they would have scripts that would be like dot back, dot back, dot back. It was just kind of funny. So like we're talking about what everyone's done. We have all these different roles. We have platform engineer, we have DevOps engineer, we have SRE, we have systems engineer, Unix administrator. You know, what is systems engineering, and like what does it mean specifically when we say like at scale? We have kind of a fuzzy term for it. So we can give this long one. I could read through it real quickly. Systems engineering and software is an interdisciplinary approach that ensures a holistic design, integration, and lifecycle management of software systems, involves coordinating across various disciplines to meet all requirements, optimizing attributes like performance, blah, 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 blah. There's a lot to it. Same thing for scale. Engineering at scale means designing and managing systems that can efficiently handle large volumes of data, users. You know, this meme kind of sums it up. You know, you keep using that word. Don't think it means what you think it means. Systems engineering and scale tend to be kind of overused, used for everything. This is kind of the way I think of it. One, you kind of know it when you see it. That's very famous within like the Linux community, but also was originally Justice was that Stuart Potter had mentioned it. We was talking about pornography. But if I had to distill it down to something that was reasonable to read to you folks, I'd say systems engineering is a multidisciplinary field that focuses on designing, creating, and managing complex systems that operate at massive scales, handling millions to billions of users and requests. That's kind of what I consider the quintessential sort of systems engineering. And as far as the note, when I see it, when I look at certain diagrams, I can kind of tell like, okay, this is the systems engineer that's developing this or designing this based upon kind of how it's structured. You know, it's not a UML diagram. We're not going into the different functions and classes and inheritance. It's not this high level sort of thing that only a solutions architect or program manager might be talking to someone they're trying to sell a product to. But there's usually some pieces that go deep within the design and a lot of pieces that are abstract or I'd say high level because they're not software developers, right? So what do you do? So it's a fairly broad field. You first of all, obviously, as it says, you manage existing systems. That's like your biggest thing as a systems engineer. You know, you might help create them, but the biggest thing is you're managing existing systems. And so with that management, you're going to write automation and tooling for those systems. It could be something like you're going through for compliance or you're looking at patching or whatever, or it might be something to help you manage like on call, but you're going to be writing or developing some sort of tooling. It's kind of baked into what we have at our company called role guidelines. You're going to do systems review and monitoring as a systems engineer. You're basically going to be saying like, how do I know that the thing that I'm responsible for is working the way that I expect it? So it's very common at where I work at that we do these sort of dashboard or ops reviews. They usually happen weekly and monthly. They happen at different levels, usually at the team level, at the org level, and then like at the, such and such complete organization wide level. And it's important to understand how those things operate. Obviously, as you move up through there, like you can't get as granular and as detailed because the teams that know the intimate details about it, they don't. But you might see that like, hey, for both the low level and the high level reviews, you have to understand how the control plane works for this service, how the data plane works, what it looks like. And most importantly, you have to be able to look at these sort of things very quickly, understand, what trends are happening for availability or for requests, and get a good sense of, hey, is this thing going the wrong direction? So I would say when we do these ops reviews as a systems engineer, you don't have to know a lot of stats like understat and overstat, things like that, but you do have to understand some of the basics. And so when they're saying like, the P99 for the availability is this, I would say like alarm on three data points of, 5 failed requests or more. Like you have to be able to intake those during the review, understand it, look at the graph, and immediately be able to understand, is there an area that is of concern that we should dive into deeper? Doc writing becomes really big, and doc reviews, I don't have it on there, but you do lots of reviews from other teams. So the people that are actually writing the code, you'll usually be reviewing some of their stuff, and you're coming at it from a perspective of someone that's not just steeped within that one system. You're looking at a very much larger system, larger ecosystem, and you're trying to apply your knowledge to whatever they're writing, whether it's a technical design review, whether it's a peer FAQ, whatever it is. You're trying to bring that sort of systems knowledge to them. Because what generally happens is SDEs where I work tend to be very focused within one field, within one subsection. So if they work for a service like Lambda, they're not going to work at Lambda, right? They're going to work on the control plane, and they're not working at control plane. They're working under like the front end invoke service or something, right? It's going to be much more tightly or very specific to that specific subsystem or team. And so your job as systems engineer is to have, maybe not that same sort of deep knowledge and understanding that they have, but understanding high level what sort of things maybe they are not familiar with or taken into account when they're doing it. So lots of doc writing, lots of doc review. Policy, SOP, runbook creation, and refinement. Again, you're trying to bring a systems engineer that sort of larger scope and knowledge. And when you're looking at a runbook, you're saying, hey, I noticed that this runbook is super vague, or we have some stuff that just doesn't make sense, or some assumptions that are built in about like how to retrieve credentials. This needs to be written in a way that anyone, even an intern, could run this. And so you will help kind of refine those run books and make sure that they're set up in a way that's going to work, or in a way that someone that's at 2 a.m. that's driving in to respond can understand this run book, because they're probably not going to have the same context as the person that wrote it. Your own call, that's one of the biggest things is you're managing systems. I don't know if your folks are familiar with DevOps. Flickr really, the company Flickr, RIP, really came up with the sort of DevOps model, but the company that I'm at really, I would say, spearheaded that and made it kind of a common thing to be hired for. So the DevOps model really says, hey, you build it, you kind of own it. And then as we've grown, that's been harder and harder to do. So we don't quite have an SRE role. We talk about the difference here in a little bit. But the systems engineer role is basically saying, you sort of work with it. You're doing the doc writing, you're doing the reviews, but you don't really build it, or you don't build all of it. You might build a piece to it. You might build some jobs that run on like a scheduler or whatever. But you're going to be on call for it. So you have to kind of understand at the high level whatever you're going to be on call for. I'm on call for a bunch of different services. So as you can imagine, with services that have 500 people, and I'm on call for like 12 to 14 of them, the knowledge that I have of those services is just not going to be the same as the person who basically wrote the damn things. But you'll be on call. Your on call depends largely on what team you're on, how it's split up. Investigations and deep dives, that's another big piece. Usually people that are writing the code, think of them as the kind of the last tier. They're going to be the ones that will be involved in those deep dives when premium support can't solve it. It gets to systems engineering teams, they can't solve it, and then it'll eventually kind of go to like the teams that actually wrote it. And then specifically the actual team that wrote that particular piece, not just like say the Lambda team. So those investigations and deep dives are a big part of what you do. You usually pick up on something that someone else has already done, and you're just continuing that deep dive, and you're trying to quickly look at a ticket with 300 comments, come up to speed with what they've done, what's left to do, the action items. And then as a systems engineer, your goal is basically figure out what needs to be done and how do I connect whatever team that knows that is the solution or the key to solving this into that ticket. That's your key. So very rarely you're the one that has like the domain specific knowledge, but a lot of times, or sometimes you do, but a lot of times you're pulling in and working with other people. Assisting and running builds. So this is kind of interesting. So builds have different contexts, like a lot of things. It could be something like, hey, I'm building an application. It could be, I'm building an application in a different region. But in general, you're doing all of those things. You're helping, debug actual builds that are failing, right? They're going through the CI/CD pipeline. You're helping build the application, whether that's reviews or something, and you're helping, build that thing in different locations or basically replicating it. So that's all of those sort of things, those different types of builds are part of it. So assisting and running builds, some teams, you're kind of hands off. You don't do any of that. But most teams you'll find as a systems engineer, you'll be doing some of that. And then it's everything but the kitchen sink, like systems engineer is one of those roles that you'll see they will have written, but then what they really mean is, they'll have some generic sort of job description that's pretty similar to maybe platform engineering or, DevOps or something, or maybe even Linux or Unix administration. But when you get on the actual team, they're going to have very specific things that they're working on, because that's whatever they've worked out with the teams that they're working with. So you might be embedded in a team as a systems engineer, in which case you won't be working on call for 12 services, right? You'd be working on call for one service and specifically one subservice. So it's really going to depend on whatever team you have. So one thing I'd say as a takeaway is if you see a systems engineer job, I talk to the hiring manager and ask them like, what do you actually do? Because you want to know those details and that they're going to be very contingent based upon what team you're joining. And it's going to change over time, right? Maybe that team starts off very small and then it's successful and then you end up taking on more services or more subservices, in which case what this looks like is going to change drastically. Okay. We've talked a lot about that. Let's go to the next one. So evolution, I'm going to try to walk through some of these real world examples. This is the part of the the presentation that got pretty light as far as what I was able to work on. But we'll pull up some of my scripts and we'll kind of talk through what changes. So basically, the way when we're talking about scale, I'm talking about systems engineering scale. We talked about a lot of things, right? And previously, or maybe this is my own personal bias. Previously, when people talk about scale, I think distributed systems, right? I think microservices. That's what I think when I think scale. Oh, they're talking about using not a monolithic architecture, but a microservice or a distributed architecture. Yes, that is true as you scale. Like you do see that there are services that tend to move to microservice or to a distributed design. That is 100% fair. But what you also see is that there are things that have to scale too, right? We just talked about a bunch of shit that you have to work on and do hands-on, like docs and reviews and stuff. So like, how do those things scale? How do your deep dive scale? Because I mentioned you might be on a team that is one subservice. So you might be on an investigation ticket. You know everyone who's going to be on that ticket. You know what you're talking about. But as you scale, as that thing grows and changes, you might be pulled into deep dives that involve, like I said, 2 other teams, 3 other teams, 4 other teams. So how those things scale up will be very different, or how you as an engineer will scale up. And I think this is where, going back to that, I'm not a great Unix administrator. I'm not a perfect Linux administrator. I do software. I do all of this stuff day to day. But if you were to compare me to my teammates that I work with, I work with some incredibly world-class talent. I don't have the PhD chops of some of them. I don't have the math skills. I don't have the stat skills. I don't have the coding skills. So I really have to rely upon the fact that I have that larger context to knowledge and be able to pull those things together. So for this, generally what I want to walk you through is like, if it's not just microservices and it's not just like, okay, you do event-based design or whatever, like what does that mean, Will? Well, let's walk through as a new systems engineer, what you're probably going to be doing. You're going to start with the infamous one-liner. This is pretty much what you get when you get hired as a systems engineer. You solve a problem. That is it. It's not glamorous or elegant. It's just you as an engineer have a quest. It could be something like, for all of the accounts that we own, I need you, Will, to figure out which ones are correctly opted in and which ones have the prod tag assigned, or whatever. Like, you need to go solve this, and the context is usually pretty ambiguous, right? They're asking you to kind of figure it out as a systems engineer. They don't really have the details themselves, and maybe there's already a tool out there that does this. As a systems engineer, I say one-liner, but let's just say this is sort of a nebulous concept of you're tackling a problem that's very localized, very specific to your team that you're working on, very specific to you. And there's not a whole lot more to it. So let me see if I can pop out to VS Code or to my shell or something. Let's see. Let's see if I can hop onto one of these. Can you folks see my MobiX term? I'm guessing not. I might have to switch.
Nope.
No, we cannot.
Okay, I'm gonna change Windows real quick. Yeah, thank you for letting me know. Let's see. Yeah. Okay. Computer enhance.
That's nice.
Cool. Okay. So this is just like a sandbox I have, right? So let's talk about real quickly, like, what does that look like? It's like a great example would be, I want you to go onto a fleet of servers, right? That you like, maybe they're ops boxes or something, or logs boxes or whatever, or test boxes, and I want you to perform some action. So you might end up doing some for loop. Basically, it's like for host, and then you say like you have an array, this is just an example, so let's not go too deep into it. But um, ops host list, right? And then we're gonna do something, right? Do a thing. Done. And that's it. You might be SSHing to it and running a command, right? So we'll SSH as like, let's say Wi-Fi at, host, and then we're just going to run a simple command, something like grep. Let's say we're looking for, like, let's say they were checking to see if a group was correctly pushed out to all of these servers. Like, you have a configuration management sort of utility or service. Maybe it's NetIQ, maybe it's something internal, it's home rolled, whatever it may be. Maybe you just want to make sure that the thing is done its job. So you might go in and say, hey, grep, whatever the thing is, let's say, I don't know, Amazon Etsy group. That's kind of a ridiculous example, or contrived example, but like this is what I would say you're doing. You're going to start off, you're not going to have a lot of context. You're going to have to answer questions like, how do I get that host list? You're going to have to answer questions like, is there a better way to find out what groups exist? Is there already a utility or a service that I can hit up? But this is generally what it's going to look like. You're just going to go through, you're going to figure out that first question. You're going to generate your list somehow. So you might do like, it's going to fail, obviously, but like maybe you're going to do that sort of ops host list. And then we're going to have some sort of, function that's going to generate hosts. Right. And so we might do this. We create the array, we figure it out, and then maybe we figure out, hey, there's actually a utility or a management service that does this, and it even tells you when it's not running on a host. So then we might flip over to that as an example. But this is quite common. You're just, let's see how many people I have on here. Okay. This is a safe one to look at. Sorry, I'm trying to remember which host I'm on. I'm supposed to. Most of this stuff is presentation, so it's ephemeral. It can be killed. Just making sure that's the case, though. So yeah, you might be doing some very simple things. They're not super exciting. Like, I don't know if you've used IMD SV2, like the metadata service. You might be hopping onto a bunch of EC2 hosts and like running some commands, or Azure hosts, whatever. But this is it. This is nothing crazy. The systems part to this is like, as we saw above, you're answering those separate questions. Where are the hosts stored, right? What am I looking for? What's the best way to go about finding that answer? And then you're just doing it. And you're probably not putting it into code, like into Git. So source revision control is probably not a thing at this point. You're answering a question to close a ticket, and you're calling it a day. And that's pretty much it. So that's the infamous one-liner. It's not just one-liner, obviously, but you get my point. You're not doing anything super complex, but you might be taking to a few things. You might be looking inside CloudWatch metrics or whatever and trying to get a better understanding, or your own internal metrics or Grafana or whatever, and trying to answer a question for yourself. But you're giving that sort of ambiguous sort of task. So let's flip back over to the window. Where are we at? Okay. So that's that's the one-liner. That's kind of where you start off with. Then we move into the sort of the scrappy script. You've got to the point, it needs to be repeatable, and you find that Control plus R is getting really freaking annoying. So what are some of the features of this next level of scaling up? Well, one, you're not just solving the problem for yourself, right? You're not just closing out a ticket. It's probably for yourself and like maybe others on the team. Maybe you want to do some sort of audit, or maybe you have a list of customer impact and you want to check which of these customers are canary accounts, which are test accounts, which are internal accounts, which are external, because maybe you want to give some more specific details about like the impact that happened for that particular like ticket that you worked. So you might create a tool that goes and do it. Same thing as before. You don't have all the answers, right? How do we tell which accounts are in which? You'll come across edge cases. It's up to you as an engineer to figure out ways to solve those edge cases. Hey, there's not a tag or a way to tell if it's a canary account or not. How can I start thinking of a way to at least 80% solve that? Maybe it's something as simple as, well, I'm going to look at the account name, and if it has canary in it, cool. It's, that's a canary account. Maybe we start looking at some other things where, like, is there a way that we can tie these things together? Is there some other sort of larger abstract concept that pulls these together? So it's still limited in scope, right? It's just for your team. You're not writing an application that's being used by external customers. It's still pretty limited. It's got some built-in fragilities, what I would say. So what that basically means is that when you've scripted this or you've created this sort of, maybe it's even a small little website, a little web app, it's kind of janky, right? Like the navigation maybe not doesn't work super great. You might be using some sort of framework like Cloudscape that helps you with some of this, but at the end of the day, like you've got something that's very scrappy that like does the job for the people that know how to use it, but documentation, not a thing. It's that bespoke, organic, handcrafted, free trade script or sort of web app. It is in source version control at this point in time, but deployment's kind of haphazard. Testing, maybe we've got some tests, but we probably don't have, if it's like a web app, we probably don't have any sort of console tests like Selenium or whatever. We probably are the bare bones at this point in time. And this is I would say if you were to be hired right now as what we would consider an L4, which is basically like you're not quite entry level, but pretty darn close to it. Entry level for corporate is what I would say. Um, you're starting there. You're starting here pretty much. You'll be doing a lot of the previous slide we just talked about, which is like you're solving things, you're trying to find that larger context and bring it in, but you're going to be here. And you don't, as you can see, there's lots of gaps or what you don't need to know because it's not really going to show up. You're not doing technical design docs for this. It's going to be like you've got a problem, you can't find anything that solves it, so you're building it yourself as a systems engineer, and you're building it probably as not a developer or not as a um, project manager or something. You're solving your one problem, and that's sort of it. So let's pop over to let's see if my VS Code is up. It looks like it's up. So let's flip over to that real quick. Okay. So hopefully you folks can see this. I'd
Yes.
say the distinguishing features that we're finding with this is like, okay, so we've got some details for our scrappy script, right? You don't have unit testing or anything like that, but we've got some structure here. We've got a usage statement. So if someone types in -h, they actually get the help statement, right? But we don't have a lot of documentation, right? This still assumes that you're working, someone that's using this is working on your team, right? We've got some additional details. Hey, look, it's getting a little bit more modular, a little bit more functional. But in general, you'll see tons of this sort of stuff to do. There's no trap statement. It's not really it's not really doing a whole lot. But hey, it's got some arg parsing. We've got some basic checks. And this is what I would say is that this is the scrappy script sort of version. You're solving something that you've done a few times. You're allowing other folks in your team to use it. We've covered some basic checks, but we still got that fragility, right? Like if you pass this in some random crap, it doesn't do, there's no guardrails there. We're not checking for details or for validation or input sanitization. We're just doing some basic stuff. Like I think if we take a look down here, we look for like port. Yeah, like we're for the opt-arg, we don't have, let's do that. We don't have any sort of like, hey, for port, we know for sure it's going to be, 0 for 9. We don't have any of that sort of like sanitization happening right now. This is just like, get the thing, make it work. And it's a little bit janky if you do something that you're not supposed to with it. Okay. So that's the scrappy script of engineering. We can see some cool things that are maybe are starting to get there. Like we've got some defaults that are being set, but otherwise, it leaves a lot to be desired. Let's go ahead and switch back to. Cool. All right. Oh no. Sorry, this is my first time using Prezi. That was a terrible fucking mistake to try to write a new presentation in a software that I don't know. It's exciting to learn something new, but 10 out of 10 would not recommend before you have to give a presentation. But I think I'll spend some time with it because I do like it as an alternative to PowerPoint. I probably won't make it my go-to just because it's a little bit more difficult, but it's still fun. Okay, tool or utility. So this is where we start to see scale. When you think of scale and you hear about it in the news or you see like a Medium article, this is where we're starting to touch upon the things that deal with scale. The biggest thing that you'll notice is that it's designed. There is going to be some sort of technical document It may not be TDD, test-driven development. It may not be meeting some sort of weird paradigm, but for sure, it definitely has something, right? There is some sort of framework. We're following some sort of model. It may not be perfect, but you're doing something. I don't have a technical design doc to show you folks. I'm really sorry. This was something I hope to get done today, and I've run out of time. But I can help write one here in a second at the very end if we have extra time, to give you a sense of what it looks like. You're going to see that's tested. It's now no longer an option that you can like just assume that people are going to figure out like what the thing does, like the web app or the scrappy script. Hey, if you press this button, it goes forward because I forgot to link that page. That's no longer acceptable. It's going outside of your team, the scope. So you're going to have other folks who are running this thing, and because they're running it, you need documentation. This could be something scrappy, right? Like you've got a XWiki or MediaWiki set up, and you've got some, maybe like a developer guide, maybe you've got a user guide, a very brief onboarding guide, but you've got something there for folks who are outside of your team to basically reference when they're using your tool or utility. It's got guardrails. So at this point in time, if we go back to that script, well, actually, we'll go back to it in a second. I'll show you some things that we're going to start doing to make this more of a utility or tool. And then I kind of ran out of space here, but we're going to start using things like libraries. We're going to start having things like testing and monitoring and telemetry on it. So, it might be as simple as just, hey, we've created a logger and it's writing to like some sort of var log, but there is some sort of logs that are just not straight to standard out. We're moving beyond just the standard out and standard error or whatever file descriptor you choose, where we're going to use that. There's a built-in logger for Linux called logger. You can specify, but you're going to find that most of these tools or utilities quickly move outside of using that. Like they're going to want to have logs go to a location. It's going to be rotated or zipped up. It's probably going to be pushed off to some custom logger like Nagios or whatever, or like I work with it within my company, so we'll use like something like CloudWatch. Whatever the case may be, it's going to go to that location in aggregate, most likely. And if it doesn't, like if you don't have it, it's still going to be in a location that's pretty discernible. So this is where we start moving into okay, we've got telemetry. We have to start thinking about this being run on multiple different boxes. So this is an operational script that you're writing that's now becoming a tool or utility. You have to start understanding that this script is going to be called at multiple times through different locations. So how do we pull together those logs, right? This is where that scale starts to happen, right? As things scale up, it's no longer sufficient just to like print it to screen or print it out. Like you need to know when your thing breaks. So a great example is I own a service called, like a utility called Ops Alchemy that does configuration and management for operational hosts. And for that tool, right? I'm in this weird spot where like it's a tool or utility, but I don't have the logs going to a centralized location. So part of what I'm dealing with right now is like when someone has an issue, what do I have to do? To give them like a troubleshooting tool and say, go run this tool to pull the logs and give it to me, right? So the scale piece is like, you don't have to do it all at once, is what I'm trying to get at. You don't have to solve every single one of these things at once, but you need to start moving in that direction when you're developing this web app or this tool or utility, because otherwise it's going to be an absolute fucking nightmare to manage when people are cutting you tickets because like, hey, your thing has broken, and you're like, cool, I don't have those logs. I'm going to need you to give me those logs. So that's kind of what I'm getting at. So let's flip back over and let's start talking loosely through like kind of what that looks like. Let's see. Let's go back to the VS Code. Okay, hopefully I'm back on the VS Code. Okay. Okay, good. All right, so we've got a bunch of crap here. Like we can just go take a look at some of these things. But I think the important piece that you can even see I'm doing some like Go testing. The important thing to know here is that you're starting to move into the spot where like let's see, what's a good example of one of these? Okay, yeah, well this is fine. Let's go ahead and this is not completed, but this will be workable for what we're doing. Okay, we've got a signal. So sorry, go ahead.
You're on the term, not the VS Code.
Dang it, dag nabbit. Let's flip to. Cool. Can you see that? Am I on the right one?
You're on VS Code, yes.
Cool. All right. Apologies, folks. All right. So this signal catcher right here that we're looking at, this is obviously like a work in progress, but this is a great example of like what you start having to do when you start making a tool or utility. It's no longer good enough that your program, like whatever, let's say, what do we do? We have some of these exit codes. What's a good example of one? Let's make a failure mode here somehow. We'll just say log. Oop. Okay. Cool. All right. So we have an example, like this is obviously contrived. I don't even know what part this is, but oh, actually, I do know what this is. Okay. Sorry. Uh, quickly putting something together. But this is a great example. So we've got some like exit code, right? But we might have something like unhandled exception, like a 127. But as you move up to a tool utility, that's no longer sufficient. You can't just lump everything into exit code 1 or exit code 127. Like you're going to start having to figure out not only better exit codes and better handling, but also like you might have to do some more telemetry and analysis of what's happening to your actual tool or utility that caused it. So if you have a web app, maybe someone's got an invalid token and they're getting some sort of 403 error, like they can't access it. You need to have more in the logs captured than just like can't access, right? And those logs need to be available to you. So you need a way to grab the logs from all of the servers, pull them together. At the same time, you need to start pushing these, metrics up into some sort of service at aggregate and then alarming on them. So let's say that you have a canary that goes through and tests your service or your tool. You want to make sure that like you're looking for a minimum volume for your service. So like at least no matter what time of night it is, the canary should always be calling the service. We should always see 200s. And so we're going to be looking for those. In the case of a script, that's not obviously it's not like an application, but a script is in the same boat. You're going to have to tell them like what signal happened. So you have to give them more detail for logging. If you like, again, you don't have to do all of this, but what you'll find is that if you don't go through these steps of getting better, better logger, better log handling, rotation, better signal handling, is that you will be constantly trying to catch up with people cutting you tickets to say like your shit's broke, right? And you have to do all of this deep diving for each individual one. That's just not scalable. And you want to make sure that you're creating things that people can use and have a good user experience, right? Even if it's not external right now, this is just internal. Nothing sucks more than being told to like, hey, your tool is so bad that we've stopped using it and we've gone to something else. Or even worst case, your tool or utility is so bad that people have recreated it. That's like, I would say in systems engineering, that is the ultimate failure, is when someone comes behind you and says, yeah, the thing that you did sucks to use and I'm going to recreate it. So in this particular case, damn, who hurt you? Java hurt me. Java did. But that's the key, right? Is like you want to make sure that we're developing things. So a great example that of something we would start doing, like when you run things like these read-onlys multiple times in the same session, you're going to start getting some weird bugs because you're redeclaring a read-only variable. So you might start doing things like guard clauses. If you folks haven't seen a guard clause, it's nothing super sexy. I'm sorry, but let's say this is server check already sourced or run. And basically what we're going to be doing here is we're just going to be relying on some behavior. Server check. True. Cool. Okay. So what this is a great example of like, it's a small thing that you're going to be doing to your scripts. Same thing for even for Go. You're going to be worrying about things like namespace collisions because you're going to be working with other libraries. So you want to be, so naming starts becoming much more important, right? Especially in the case of like this, you're going to start, you can't just use things like unhandled exception. Like one doesn't tell you anything. Two, it might collide with a different script or a different library that you're sourcing. So you'll start including naming becomes a bigger conversation. However your team does it. I don't care too strongly. I've worked with so many teams that feel very strongly. I just don't give a shit. What it's more important that you stay consistent than that you are, doing one specific type of naming. What's the old quote? There are three things that are difficult, or sorry, two things that are difficult. Naming, cache and validation off by one errors. This is kind of a great example of that. So we have some basic things that we're going to start doing to the script. We talked about it briefly down here, but we're going to start doing things like making sure that we know that something should only especially for languages that are untyped or duck typed like Bash, if we know that the language allows you to kind of fool with it like Python, we might start forcing things to move into a certain direction. So it's more closer to a typed language. So we might say, hey, if this thing does not begin with like a 0 to 9, toss it off. That sort of thing. Same thing for count. We'll start adding, again, more logging, more sort of checks. We'll start pushing some telemetry. So during these things, we might be doing things like this. Log, debug, starting, function, whoop. And then we might say like, I think it's this, func name 0. Or maybe we can say trace. That's a great example. So as you get larger, even things like log levels become more important. If you're looping through a lot of stuff, right? And it's very important that you do look through that iteration. You might start moving from like just using debug and like standard out to like, okay, we're going to use debug and we're going to use trace anytime. It's very expensive pushing this to standard out for this huge loop. So I'm going to only enable this when trace debugging is enabled. So you start hitting those sort of things, which, it's not sexy, it's not microservice, but it becomes very important that you have good understanding of how you're operating and setting up your scripts for log levels, because that's going to make them ultimately usable and start scaling, right, as you start doing things. Okay, so we're moving from this. If I'm not a front end developer, but I can tell you some basic things that you would want to do as far as like that sort of side is like, one, you're going to start having a load balance in front of your stuff, right? You can't have a single server, whether it's horizontal scaling or vertical. Like you're going to find that after time with the tool utility, vertical scaling just ends. Like you can only get such a large box. And it gets more expensive to have those sort of dedicated boxes, where it gets much easier if you can have a bunch of commodity sort of instances or containers, and you're just routing the requests to those containers. And they're kind of stateless, right? They don't care. They just service the request and they send it back. So these are all, I would say, yeah, state is the devil. These are all key things, but you have to start worrying about state, right? Like, we still have to start worrying about mutating changes in ID and potency. So for our scripts, maybe they're doing something that's mutating and they're changing it. Like maybe they're enabling SE Linux or whatever. Like we want to start making sure our scripts have some additional checks. So we might start doing something like validate already enabled, right? And then we might start doing that sort of stuff where we do a check and we say, grep for, or if let's look, we might wait look to see if a file even exists, like a lock file var, temp, process lock. Nothing super exciting, but or maybe we even move from there. We even use lock, right? I don't remember the exact commands for the file lock, but whatever those args are, and then we give it the that thing, this file. Oh. Or maybe we find that that's kind of annoying, so we start doing no file lock or lock file. So we create a variable, we scope it locally, no one else needs to see it or use it. So then we start updating this. These aren't super sexy things, right? But this is all, I would say, majority of what you're going to be doing in systems engineering is this. This doesn't sound exciting, but this is what you're doing. You're starting to think about, okay, how do I refactor existing scripts so they handle things like state, so they handle things like being able to pull in customer logs that are using my utility. Sorry, it's just going to complain until I give it something. But yeah, so these are all things you'll start doing things like interprocess communication or file locks. and you'll start having to usually update existing scripts so that they do things like this. So if someone's running something on the server, maybe when we want to create a sort of I think it's X for non-shareable, whatever the exclusive lock is for a file. But that's the key, is like you're going to start working with additional things. Your trap statement no longer becomes optional. You're going to have to clean up the stuff that you do. So if you're like unzipping tar files, like maybe you have a list that you're passing in, you're going to have to go in through and delete those files. That file clean up array. Maybe we want to do like a for loop for do run. And again, we want to have that logging. And if there's any sort of error, if does not equal 0, and blah, do a thing. Maybe we want to push them to telemetry, so we'll do like, maybe we'll do an AWS CloudWatch command and push it. Or maybe we have like some sort of alias to it, push metric or log failure metric. All right, and then we're going to do file. Sorry, we're kind of jumping around. I apologize. Okay, cool. So we're in this sort of spot where like we're going to be doing things where we're going through. Not only are we trying our best effort to do something, we're also trying to handle the situation that arises when that doesn't do it. And we might even exit something specific like server check failed to clean up files. So this is again, I think most folks are familiar with like microservice and stuff. This isn't super exciting, but this is a lot of systems engineering right here. And not only it's like then going back and updating the documentation. If you're using something like natural docs, because this is a bash script, if you're using something like natural docs, you would want to make sure you go over all the functions. However it expects the comments to develop those or auto-generate those docs, you would do that. If you have like runbooks that uses utility or tool, you would do that. That's the key though. So I think we've definitely harped on it too much. So we'll switch back to the slides. Okay. Cool. So this is the thing where people think of when they think of scale, right? Service. I have service in quotes because there's a few different levels of service, but generally this is what happens. When you go in, you make a service or you're working on service. Some of the core things that change is you have a service level agreement. There's real dollar value to when you screw something up, even for investigations or remediation. When that service is down or it has less than like 99.5 availability for a certain length of time, you'll find that if you, the engineer who's on call or who's helping the thing, if you don't solve that in time or quick enough, there's a significant monetary cost to the organization and customer experience, right? I think most of you as folks, were familiar and experienced the CloudWatch outage, or at least heard about it. This is a great example, right? Like as you scale up, you're now customer facing. And so bad design, bad choices really, really become painful. You could get lawsuits. You could fuck up so bad with something or compliance wise that, one, there's an investigation into it. And then further, that investigation then leads to more issues because then when people put a magnifying glass of what you're doing, you'll start seeing all the other things that crop up. Like, oh, you say that, your organization for compliance says you do this, but like we're looking at what you're doing and your run books and SOPs don't have that. Change management becomes much more of an onerous sort of process. Yes, other things might have change management forms, when you do it, but you'll find that to do updates and stuff, if it's not fully automated, the change management gets pretty onerous. You'll have a bar raiser, you'll have reviews, it'll go through maybe a change management meeting, it'll be scheduled, you'll have to avoid outages or blocked or awareness days. The design process is significantly lengthier and a wider audience. You might have principal and staff engineers that are on because they're looking at this, they're providing perspective. You usually have folks outside of your organization, they're helping look at the design. Maybe it's for a new feature or for a console update, could be anything. The deployment process, and I won't rehash what the other talks I've already done for CI/CD, but that process increases. They might say, hey, we want to see a Fibonacci deployment sequence. We want to be really sure that if something were to happen, the blast radius is reduced or contained to maybe one region or a subset of customers. You'll find things like one boxes or QA boxes are no longer just best practice, but they're now required. There's going to be on call for your tool or your service. Like, again, I'm on call for some of those services. There's that legal security and compliance again. You might have like FedRAMP compliance or something else, or ITAR, HIPAA, anything that you can think of. And you might not be aware of who your customers are, but like security and legal and compliance, like they're the ones in charge of making sure that what you're doing is meeting sort of the spec and the letter of the law, or that you have a what they call a POA, plans of actions and milestones, I think, or POAM. Basically, you have a very concerted effort to close that gap, and there's a map of how you're going to close it and a timeline for it. You'll find there's pen testing and AppSec reviews. It's no longer okay enough for you to like manually test out your script, do some fuzzing, feed it some random stuff. Like you will have either automated testing, or most likely you'll have automated and manual testing done. Documentation. This is stuff that's going out to customers. It's going to have its own deployment workflow. It's its own people are reviewing it. You might have your own technical doc writers. And you'll have to work with those technical doc writers to make sure that their writing would actually make sense and what's true and accurate. So if you're giving things like quotas or limits or throttling, you would have to work with that team. And it's basically turtles all the way down. Everything that you can think of just becomes that much more complex, that much more down. So this is why when I was talking about systems engineering, lends itself to those previous jobs. Is if you think about something like bartending, what are you doing in bartending? You're trying to quickly understand a situation. You're trying to understand what someone wants, and you're trying to build a rapport with them. And what are you doing here? You're working with other teams. You have to build a rapport with them. You have to get them to buy off of what you're doing. And so, like, I would say a lot of experience in bartending was very useful for this. If you talk about like my background in religious studies, you're dealing with people, and especially in design reviews, who have very strong feelings on design, right? So like for consistency, right? They might feel very strongly that like eventual consistency is the way to go. These are the reasons, or hey, you cannot use a relational database. It has to be NoSQL. And so, being able to view things through different perspective or different lenses is very important in IT, because as much as it sounds like we're dealing with black and white, we're dealing with binary 0 or 1, you're really not. The lowest levels may be that, but as you build complex systems up, you have all of that intricacy and that sort of gray area and nebulous sort of stuff. And there are different teams that do things different ways. And so being able to view it through their perspective, not get into this sort of, pissing contest of, well, this is the way that I was taught and this is the way that always works, And sometimes you're just kind of constrained with existing situations. And so you have to kind of work within their constraints. So that becomes important too. Unix and systems administration, obviously, hopefully you can see how that translates. But if you don't, as a systems administrator, you're figuring out how to solve problems, usually at the Linux or the OS level. That translates directly to this. Now, granted, you're going to have to start solving those problems, not just on a single host, but like host wide. So, and usually you move out of the category of bespoke hosts. Everything is cattle, so they kill those hosts. So like your troubleshooting no longer becomes hop on the host, bring the network up or down, or do like a system control reload. You don't do that anymore. You would execute that through some sort of framework. But that knowledge as a systems Unix administrator to understand what's happening when you execute that framework, I would say is critical, right? It gives you one confidence that you know what's going on, but also it helps you understand when like, they're saying that that's the case, that we should just, scale this whole ASG up and scale it back down again and just, refresh the whole fleet. But I don't think that's the case. And actually, based upon my knowledge as a systems or as a, Unix or Linux administrator, I know that there can be some file contention issues, or maybe, we have like the out of memory killer. You start being able to leverage and bring that skill set into what you're doing. And maybe you go into CloudWatch logs, you start looking for some of those things that and then that allows you to make better decisions, even though you're no longer being hands-on on a single server, you're working at scale. It allows you to kind of figure out quicker, reduce the mean time to resolution for those sort of things. Okay, Jesus H. I know we're kind of going over time. So what am I doing these days?
Oh no, you still
Learning
got time.
Okay, cool. That's right. There's 25 minutes left.
Yeah, but you
Okay.
can talk as long as you want. You're the last one.
Oh, awesome. So what am I doing these days? I'm learning to move with the chaos of a 1-year-old. I still work at a large tech company as a senior engineer. I'm a climbing coach. We just had climbing nationals for our team, so I've, very exciting that we had a bunch of our athletes go to nationals. But as you can imagine, with a new kid and with a big job, it's one extra thing to do. I do certs and skills development. Obviously, that's been kind of on hold for the last 10 months, just because I trying the certain skill I'm developing right now is being a parent. I recently got a grill, so I've been doing a hell of a lot of barbecuing and trying to get the dog and the baby not to kill themselves or burn themselves off the grill. But that's been a blast. I still do hiking and alpinism a lot. That's kind of my way to zen out. The stress levels are pretty freaking high right now, especially with a new house, a new kid, and all that sort of stuff. I'm a Twitch streamer on occasion. I'm hoping to get back into it when I get things stable, like a house that's not in shambles. And then I sleep whenever the time presents itself. That's one skill I've learned as a parent, and I'm a big fan of. So I guess for you folks, like, who gives a shit? What were the key takeaways? So hopefully this provides a little perspective on like what a systems engineer is. And, as we've talked about, it really depends, right? You could be in a job that is still hands-on with those hosts, right? You're still doing things, you're hopping into those scripts, doing like what I'm doing, or you could be moving up and like you're not touching hosts directly anymore. You're working entirely within infrastructure as code or SSM or some sort of configuration management. There's a flywheel to this. Every experience that you have, don't tend to think of it like I just need to get another cert. Like any experience that you're gaining, even as a dad or as a coach, where like it's going to apply. There's going to be some skill that's applicable to where you want to go. And the more you can kind of leverage those skills into your current positions, the more it's going to make you more effective as an engineer. And like again, I'm not an amazing coder or Linux admin or anything. But any of those skills that you have, the more you can do them, the better you get. The better you get, the more opportunities you get. It's that sort of virtuous cycle. The less is more. You're going to have to really figure out when you get to this large level, especially in systems engineering. As you saw, there's just no way to focus on all that. You cannot become an expert in every single one of those things in every single language. So the less is more is you're going to find out what is going to move the needle for what I'm working on currently, right? Maybe that's working on your doc writing skills. Maybe that's leveraging Gen AI to make more effective promo reviews or interviews or whatever. You're going to have to choose because there's just not enough time in the day to become an expert in all of those things. The root of all evil is incomplete context. I don't know if you folks know this quote. It's by Donald Knuth. It's basically what's been taken is over time. People have always said, the root of all evil is premature optimization. But there's sort of a longer quote to it, and I kind of want to read it to you folks because I think it lends itself very well to systems engineering. Programmers waste enormous amounts of time thinking about or worrying about the speed of non-critical parts of their programs. And these attempts at efficiency actually have a strong negative impact when debugging and maintenance are considered. We should forget about the small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. Yet, we should not pass up our opportunities in that critical 3%. And this is important enough that I'm going to copy this and post it in here. Because I think for systems engineering, you can see kind of how that quote lends itself to this. As an example, let's say you have a Lambda function, you have a paging service, right? So you're taking pages, you're trying to decide whether they're after hours or not. So you're referencing some existing data in like a DynamoDB table, whatever. You have an event-driven design, so it's coming through like an SQS queue, or it could be a Kafka, anything, any sort of queue service, right? You got the queue, you've got some sort of serverless service that operates off that queue, and the details are that you are trying to think of, okay, how do I design this thing? One premature optimization is I'm going to flip from Python to Rust. You have zero fucking idea that switching from Python to Rust is actually going to produce any sort of benefit. And if it's a language you don't know, you're incurring a lot of time and maybe not a lot of benefit. So the key is you need to measure and profile everything you're doing before you make that change. So the key there is, that sort of decision is premature optimization. You're deciding something, you don't have any sort of context or anything to back that up. You're just sort of saying, I've heard Rust is very efficient, and so I want to use Rust. But I don't know Rust. That's premature optimization. Premature optimization is not making good design decisions. Like that, good design decisions are not premature optimization. That's a better way to say it. Saying like, hey, I know when I have a queuing service and I'm operating off of that, I have a few options. I can batch those responses or I can do them individually. If I don't batch them, the cost of executing this, Lambda function or whatever is X dollars. If I batch them, it's reduced by X amount. That's not premature optimization. That's good design. As a systems engineer, that's what you want to focus on. And if you're not familiar with those sort of things, or hashing or eventual consistency, whatever, your goal going back to that less is more is to focus on those areas that are going to drive the best decisions. So hopefully that's helpful for you folks to understand the incomplete context, the root of all evil. And then lastly, scale is dependent. A lot of the examples you saw are not microservices, right? We're making things scalable, but it's not in the traditional sense of like, oh, you've got billions of users. We're talking about moving up from like within yourself, your team, your organization, maybe externally facing, and then like a large service. So the changes and things you're going to be doing are very dependent upon that scale. And then what you're going to be working on and learning is going to be dependent upon that scale, At the lower team level, you might not work with compliance because nothing you're doing is being used by engineers outside of your org. But when you move up, maybe you start having to work with like AppSec reviewers or pen testing or some sort of testing software. And maybe if you're like me and you're just garbage at front end, maybe you don't know anything about Selenium or any sort of console tests, but you're going to start having to spend time to learn those so that you can be an effective systems engineer for that particular problem. All right. Whoop. All right. And so this is the QA portion of it. So you can feel free to talk shop. We can follow up with me in Discord. You can ask pretty much any sort of questions you have about as long as it's within reason. I'll try and speak candidly and honestly about those things. Yeah, and I'm a big Scotch fanatic, a big Scotch fan. So if you folks want to give me some recommendations, I'm all for that. Or I can give you my recommendations. I'm also a Japanese fan too. I don't know if you folks can see, but behind me there's a shelf of whiskey. But yeah, so those are the details. The floor is open for anyone that wants to Hibiki. I don't think I have like Hibiki Harmony, but that is one of my go-tos, Hibiki Harmony, when I could find it for a reasonable price. Yeah.
Sending. There's a few enough people that you should be able to turn your camera on if you want.
Oh, cool. Awesome.
I think anybody that wanted to turn there's a small enough amount. I think there's only 23. I think everybody could turn their camera on if they wanted.
Okay. Coolio.
That's completely optional for you guys. You don't have to do it. Nobody's saying you have to, but you can. You ask them questions, hang out. We're pretty much done. I got to hop on a work thing, so I'll be here just kind of listening, but I will see you guys. Excellent job.
Oh, Scott, thanks so much for putting this on. I really do appreciate it and the opportunity to. I know I was kind of a wild card last minute, but I do appreciate the opportunity to present.
I want to get you guys back streaming again. All you guys that are like blowing it out of the water, like, man, you guys would like, I would be like, just like watching you guys and rating you guys with like 10 people when you guys have like hundreds. So yeah, I think you guys are all.
My goal is to get back there, Scott. I just need to wrangle a kid first. So
all right. Take care, guys. I'll be around.
And we can also talk snowboarding, rock climbing, whiskey, like lock picking. I'm happy to talk about my hobbies as well. We don't have to talk just shop.
Hey, how do you find time to do all this? Like, house and
I don't.
kids and
That's part of the problem. I don't find time to do all of it, so I have to kind of choose, and I'm probably doing a bad job right now, to be honest. If you choosing like what it's really whatever's most important, like this presentation, whatever comes up first is like what I spend time on. But I hope to get back to the spot where I can like have dedicated time to like lockpick or play games or hike and stuff. Right now, I make time for hiking and for just going out with like my dog. I have a German Shepherd of a 3-year-old named Phoebe. She's my adventure buddy, and that's what I make time for, because like that's just mental sanity. If I didn't have that, I would lose my freaking mind. But otherwise, like certs and stuff, it's like right now we're in promo season, and so like I'm doing nothing but interviewing and promo doc writing and tons of meetings. So, and then trying to do coding at 2 a.m. in the morning to get like things above the finish line. But yeah. Thanks for
Thank you.
the shout, folks. I'm glad you folks enjoyed the presentation. How did I get
Yeah, it
into
was pretty good.
lockpicking?
Yeah. How do
I
you
got
get
into
into
lockpicking because that same roommate I had in college that was the Linux like head for the school. He was a lockpicker, and so I just picked it up, pun intended, because he was doing lockpicking. So, and then again, I feel kind of bad that like he was a software. He's a staff engineer now, but he was a big Linux fan and really big into to Bash and into Java, and I just missed the train on that. If I could go back, I think we'd be better friends now because I'm much more into the things that he's into. So honestly, they kind of do. You gotta spend some time to get into Linux or to lock picking. I feel like that first lock that you open, the first time that you kind of get a sense of how to navigate Linux, and you build up the mental model of like how things are laid out. I don't know about you, but like for me, it's that initial steep curve that kind of like I don't know if I want to do this, but once you get past it, it's addictive because you start getting really good at like finding alternatives and stuff. But yeah. I'm very hesitant. Oh, don't worry about having to invite me. I'll show up and help you out, Robo. I will say there's been 3 occasions where someone needed to get access to their house. They were going to pay a locksmith, and I came out and lock picked the doors for them and got them in. We have a lockbox outside, like for mail for the new house I'm in, and they didn't have the key, and they were going to have me pay like $150 for someone to come out and take one of these little like wafer locks. I was like, get the fuck out of here. It took me approximately 30 seconds to actually, I think I have it. Yeah, this little wafer lock. Like this thing was super easy to pick, but that's from my mailbox, and so I saved myself a good $150. But yeah, any questions about systems engineering or how to get into it? Like I said, I do lots of interviews, so I can at least help out with some of the areas to focus in if you're curious. I know it shares a lot in common with DevOps and SRE, but there are some things that are specific, I would say, to systems engineering. More of a system. Okay, I would say, coming as a systems admin, I would say that a sysadmin is a great person to be in as a systems engineer, because a lot of the questions you're going to be asking, like your phone screen or your loop, are going to be about like Linux. And so right out the gate, if you have the Linux skills down and you could talk about things like it's going to be team dependent. Like, obviously if you're dealing with a networking or hardwaring team, like they might ask you things that are more, focused into like, tell me how you would like trace a file call or something for for a failed mount. That's going to be different than like someone that just has general Linux skills. Like, hey, I want you to show me how to chown a file. How do you check to see if the files get the right permissions? How do you check if SE Linux is enabled? But in general, like, those are all things you can easily cover within, a day or two. If you have a strong Linux background, you figure out whatever they're looking for. You brush back up on the RAID configurations or whatever, if you're applying to S3, and then, you have that portion of the loop that's totally knocked out of the park. So I think personally, if you're a Linux or Unix sysadmin, you're a great candidate for a systems engineer, just because you'll have that sort of that big core part of OS fundamentals and troubleshooting down.
You said that you do interviews, right?
Yep.
What kind of questions do you ask your interviewers? What kind of stuff do you look for in them as well?
Yeah. So without giving away my interview questions, I don't want to do
Okay,
that.
sorry.
No, you're good. I give an example of one.
Sure.
I don't like asking trivia. So, there are some red flags, right? Like if we're talking about SSH and you don't know that runs on port 22, like, maybe it's a little bit of a like, it's not great. But I try not to ask trivia questions like that. Instead, I try to see how you solve problems. So I'll give you something like, hey, you joined the team. Congratulations. Teammate asks you to run this command, called the foobar fizz, whatever. And it says you get this error back, and I'll give like the string there, bash colon dash, fizz baz, whatever, command not found. Walk me through how you begin troubleshooting. And so for me, what I'm looking for is that person to start branching off. Do they understand pathing? Do they understand how to make pathing or make updates to it? Make it, persistent across reboots, logins, logouts? Do they understand how to check for permission bits? Can they actually find the system, the command on the system of like find? Do they know how to use stat or file or type or whatever? So I'm not looking for any specific one, but I'm seeing you as an engineer, what sort of things can you pull on that you kind of know about? So as a great example, like if you do a find command, I might give you a follow-up question that says, oh, you do the find command, find, you start at root, you do dash name or iname, and then type file. You don't find it, but you talk to a teammate and they are able to find it on the system. What's up? This might be a push to see if you understand symlinks, if you're able to understand like the fact that a find won't traverse across file system boundaries for like an NFS share. So that's, those are the sort of questions I would ask. I might ask you a systems design question. That'd be something like, hey, you have a config, you have a list of servers, and you have to push that config to those servers. Walk me through how you would design a tool or system to do that. And that's open-ended, right? But like you as an engineer get to decide, do you actually want to write the code? Do you want to do the pseudocode? Do you want to talk high level deployment strategies, rollback strategies, validation testing? Like the sky's the limit in those sort of scenarios. And basically what we're doing, and this is the common strategy within my company, basically what we're doing is we're allowing you to lead wherever you want to go, and we're allowing to see what you know, right? And you get to kind of dive as deep as you want to. Thank you, Robodom. I really appreciate your time, man. Take it easy. Does that sort of help? Now, to be fair, the company I work at has over 1 million people employed. I can't vouch for every single interviewer not asking you trivia. So like, you might get just a bad luck of the draw and you get someone who just sucks at interviewing. And I'm sorry about that. Like that does happen. And they might just ask you like, what port does DNS run on? Why does it run on DNS 53 for TCP and UDP? Like, that's just not super helpful stuff, but you might get some of those unfortunately those interviewers. But in general, you'll find those sort of questions I ask is open-ended ones.
No, it was really helpful. Thank you. I was just gonna ask you. You said that you cannot find files that traverse through NFS shares. Is that correct? I've never done it.
Yeah, you'd have to do something like find -L to make sure like you're following the symlinks. Find by default. I mean, it depends on the distro, but find by default for the systems that we work on, which is like Amazon Linux and RHEL, they won't traverse the separate file system. So you will end up with a find command that doesn't find something. Even though it exists on the system, obviously, and that's a great point though. Is like if you work with a specific distro, like you would want to call that out in the interview. Like if you don't do Linux at all, but you do Windows, Windows uses Path, but there's some things that are special about how Path is done in Windows. So like all the thing you'd want to do is like tie it back to what the interviewer is asking. And the biggest thing I could tell you is no matter what happens, don't end the conversation with "I don't know." You would say, I don't know, but this is where I would go to find more information. This is my process for kind of solving those sort of things. What are the biggest red flags you see for resumes? I don't look at resumes. This is controversial because a lot of people feel strongly that you should look at resumes. I don't want to be biased. Like from my perspective, I don't want to see your name. I don't want to know your race. I don't want to know your gender. I don't want to know whether you have a college degree or not, if you're in the military or not. I just want to know, can you answer the questions I'm asking? Can you do the job? Full stop, right? Obviously you have to make it through recruiting through that first pass. So you need to have a resume. You need to have something that defeats ATS. But for me, the way that I interview, I don't care. I generally try not to look at interviews or about resumes. But in the case where something goes off the rails and I go and look at a resume and I see that I ask a question about Python and like maybe it's the GIL, right? The global interpreter lock. And the person says that they are a Python master. These are actual words that someone has written. And they don't understand, they've never heard of the GIL before. Then like, that's not great, right? Because it shows the person is not aware of what they don't know. And that for me in my role, for an L4, maybe that's okay, but for like a senior engineer, that's a no-go. We want people to have a clear understanding of their gaps and their limitations and to be familiar with it. And the Dunning-Kruger is kind of in full effect, unfortunately. So you just want to make sure, yeah, exactly, Reed. You just want to make sure that whatever you're putting on your resume, you can speak to. I understand you get to stretch it, some Twitch streamers and stuff will straight up tell you to lie. I agree that you got to get in front of someone, right? You do. So you got to do what you got to do. But I would say for me, if an interview goes south and you've somehow made it onto my loop, the first thing I'm going to do is go look at the phone screen and then look at your resume and figure out how the hell did you get into the loop. And at that point in time, the downside, you might say, like, who cares? Whatever. I got a loop. So what if I didn't get the job? It's because generally, if you have a really bad loop or a really bad phone screen, in this particular case, you can be put in for a non-recyclable time. And basically what that means is like you're blocked from applying to that company for X amount of time. Could be years, right? So you don't want to blow your chance, is what I'm trying to say. Yes, does it get you in front of someone? Can you kind of lie your way through it? Yeah, but if you end up blowing your chance with that team and they basically put in there, not for recycle for at least 2 years, like, dude, you can't apply to any role or position in that company for 2 years. Like that's a lot. So yes, I understand and I hear that sort of perspective from some Twitch and YouTube streamers about like, you got to do what you got to do. But I would just caution you as a red flag, like, if you abuse that, like you could end up in a worse situation. And some companies share recruiting software, and so like you're not just being blocked from that one company, you're being blocked from like any company that uses that. So it's just, I would caution you to put on the resume which you can speak to, stretch the truth a little bit. If you've worked with Python, you can at least do a hello world. Then you could say, I've got some awareness of Python, or I've used Python, or use some sort of term like that. Just like, hey, try to you kind of work around it a little bit, but don't put on their Java and you can't write hello world in Java like that. You're going to end up in that sort of blocked state because people are going to have a bad experience. So, does that answer your question? Hopefully. How many qualified candidates are not being interviewed because of ATS filtering? I have no idea. And I hate that software with a freaking passion. Unfortunately, it's not even, I don't even have visibility into it, right? So it's not even something that I can really help you get around. It's just something that's going to happen if you're in the industry and you're working. Yeah. Their ATS optimized templates. Hey, you know what? Look, if you put white space and a bunch of keywords in there, like, look, if they're going to use ATS to filter out candidates, I think that's fair. I think that's fair. That's me. And recruiters are generally, they're just going to do some high level filtering and then move you to a phone screen. And so I feel like if you use some sort of thing just to get in front of someone, but you've not lied on your resume, then I think that's fine. What non-professional experience helps an interviewee? Someone asked above. Non-professional experience, you're going to have to work with people. So a great example is I had without giving out any identified information, we did a senior engineer, systems engineer, a little while ago, and they were technically incredible. As far as the Linux questions, they could answer every single question. They could file something down. They did a better job of like strace than I could do, right? They were able to really answer questions in different ways. But one reason we almost didn't hire this individual, right? You're like, okay, they're stellar. How was their coding? Coding was excellent. They knocked it out of the park. System design question, did a really good job, knocked it out of the park. They developed like a garage system or something, some ridiculous thing. They were difficult to work with, and they had an attitude of, well, I told you so. And so they almost didn't get hired. So I would say non-professional experience, you have to be able to work for other people, swallow your pride, and really learn when not to say something, right? Because in an interview, like if you say these things, someone could literally say, look, we're a team. And even if this engineer is a 2X engineer, we have a team, not two people. So it doesn't matter how good they are. If they're going to cause issues on the team, and slow us down, then like we're not going to hire them. There's been so many technically sound engineers that are brilliant that have not passed through, way smarter than I am, that have not gotten a job at my company because they're difficult to work with and they have a know-it-all attitude. Or the worst case scenario is like, maybe we have to give an example of disagree and commit. And they mention, oh, I told them that this wasn't going to work. And so they really didn't put in an effort to make it work. And then at the end of the example, they're like, and I told them, obviously it wasn't going to work. Like that's not those are all things that are not technical that are going to prevent you and hamper you from getting a job. Can the opposite be true? As in you are too complacent and don't like to push back? Yeah, that's also true. Like if someone's doing something shady in your example and you don't push back, like, maybe it's a compliance issue and someone's doing something that they shouldn't do, as far as like maybe pushing a change that didn't get reviewed appropriately, then like, yeah, that can also be the reverse. That can be true too. Use cloud. What else we got? One of my leaders says he uses a two-factor check. Do they know their stuff and do they play with Reed? I think that's a great way that's a clear, crisp, and concise way to put it. Humility, patience, trust. Yeah. There's a high bar that you can set for others to follow you. Yeah. And again, like, I mean, as you folks have probably seen, like, I'm not probably nearly as strong of an engineer or mathematician as you or a stats person, but like, being a senior isn't just being amazing in one of those fields, right? You've got to be pretty good at different fields, working with people, be able to do promo reviews, right? Write docs for folks, have things reviewed, be able to take critical feedback. That's been the hardest thing for me, is that you develop a design or a doc, right? You put it out there, you get 20 or 30 people reviewing it. They're like marking it up, and you have to not take it personally. It's at the end of the day, it's a sandcastle, and you have to remember this is not a reflection upon you. This is a reflection upon making the best decisions for the company. And so for me, that's been a challenge, is not taking it personally and being like, okay, this person's like calling me out. Like, no, they're trying to make the design the best design possible and making sure we're making the right choices. That's been, that's also a really good thing for you to have as an engineer. When do you think your baby will be ready to snowboard with you? We are with another parent that we do like a little parent meetup. She's a snowboard instructor, just to be clear, just to provide context. But they're already taking their kid out. I think their kid was 9 months old, so barely able to stand, with help, and they were doing it. So that's crazy to me. Like that's insane. I'm not going to do that, but I'm maybe 2-3 years old, we'll look at doing something like where we're just 20-30 minutes, put them on the board. They're not going to be happy. Just get them kind of used to it. We won't be doing a lot of snowboarding. We'll be doing mostly just, can you be comfortable in the cold? So oh man, yeah, I'm curious to see if he's going to pick up on climbing like his parents, or if he's just not going to be interested in it. Hopefully he's interested in climbing. But Phoebe's adventures. Yeah, Phoebe's she's a pretty adventurous dog. We go on pretty large summits and hikes. She's not a huge fan of heights, so any really strict crossing that's like maybe 4 feet or less, and there's a few hundred feet on either side, she won't do. But in general, she'll go up with me, in 11-15 miles. So she's an incredible pup. I really love her. She's insane about snow. So me and her love going on snow hikes. And so we'll go to some territory that's AVI safe, and we'll just go out there when it's miserable and blizzarding because we enjoy it, and no one else is out there, and so she loves to frolic. And I think I have a video I'll post into the Discord of her just like diving into the snow. It's hilarious. Classic German Shepherd. Where can someone learn soft skills that they need to develop? There's a plethora of technical. Yeah, this one's tough. I'll give you the quick answer. Just do a session where you write a doc and then you present it to someone, and then you have to walk through the doc with them, take feedback, and then make adjustments to it, and then develop the thing. Like that's the best way to get that soft skill. One, you have to explain what you're trying to do. You have to do that technical writing, right? You have to take the feedback, learn that skill. Like, okay, I disagree with them strongly, but like I also need to learn how to just accept it, hear what they have to say, nod your head, and then at the end, if you feel like there's a good reason for a rebuttal, figure out a way to do that rebuttal. So like if it's like the classic tabs versus spaces, you say, well, we're going to use Go, and so it's not an option, it's auto formatted. So just as a heads up to you as the person that's reviewing my doc, Go doesn't really allow that option, so it'll be auto formatted. So you would just want to go through the whole process of coming up with something to do, something simple. Don't go crazy. Design a system, do the document, write it, get it reviewed. Could be in this group. Could have Tanis do it. You could have Scott and the other folks review it. Take the feedback. Learn how to let that feedback pass through you. Take the feedback, reincorporate it into the doc, and then develop the thing, and then do basically CRs, code reviews, or I think they call them pull requests. Sorry, it's an internal way that we refer to it. Take that feedback in the PR, learn how to get something delivered, and that's going to take you through the full gamut of soft skills, in my opinion. That's the best way to do it. Toastmasters, yeah. Treasure, you're right on. That's basically the equivalent of Toastmasters. I know you can also do Toastmasters itself. I don't know what the cost is, but some places have, pretty cheap cost for joining Toastmasters. It's worth it.
Does my mic work?
Yep, it does.
Hey, I just wanted to pop in and say hello and thanks for this presentation. It's a great
Hopefully
weekend.
it was helpful, Treasure. Hopefully you folks, like I said, I know this was kind of last minute pulling it together, but hopefully there's some details in there that were at least intriguing, or maybe you just enjoyed the memes.
Yeah. Well, thanks for doing this, and yeah, I'd like to recommend Toastmasters. It's a club where you learn how to speak with people. You're prompted to speak on subjects that you're not familiar with, and you get to meet people from different fields and kind of figure out how to communicate your expertise to people in a way. So I thought I'd just pop on and kind of promote that along with Het.
Yeah, I did Toastmasters I did a conference for our company on the East Coast, and one of the requirements was that you would have to present within the own internal Toastmasters, and it was good. I didn't realize that I was using lots of internal, like I was using enough technical terms and stuff that was causing issues for understanding the content of my slides, and it was great to really have them give that feedback. I say a lot. They gave that feedback. Hey, walk through these slides, make sure that you're trying to reduce the number of times that you're using those filler statements. It was pretty darn good. I can't recommend it enough. I haven't kept up with it just because it costs money and I don't have time. But especially if you're giving a presentation and you're
But you
looking
have all the communication skills anyway, and you're constantly practicing by streaming and being in this group. So I mean, for you, I wouldn't say that you'd even need it, right? But I just wanted to recommend it to people in the board. But yeah, I guess
do
I
you
just had
mind
to.
linking them to it so they can find their local chapter?
Oh yeah,
I know
yeah.
that was kind of a struggle for me to understand kind of how it's laid out.
I guess I just had a trivial question as well. Like,
Sure.
what you were mentioning Go earlier, and I was just wondering how that works into your engineering job.
Yeah. Do you mind if we take a very brief hiatus, folks, and we go over to a Go file real quick? Just pop
Yeah, sure.
over, change
For sure, I'm
windows.
just going to mute.
Let me see. Where is my VS Code? Come back to me. Okay. Let me know if this is showing my VS Code. Sorry, I'm having a hard time seeing.
It's showing you're not bad plus right now.
Ah, damn it. Okay. Well, that's got some good information on there too. That's from another talk. Let's see this. Okay. Yeah, so the Go standard out impact, here we go. Like this, I think this is actually where Go run. I can't remember exactly what I was testing. Okay, cool. And then let's do the reverse. Let's do that. That's using the logging utility. And then this is with just standard out, basically using printf with Go. Oh, sorry, I forgot. I trace debugging's turned on. I apologize. Jesus H. Basically, so this is this is the long one. We were having an argument. This is going to take a while. We were having an argument about the impact of using the loggers versus just echo and printf standard out and using different log levels. And we wanted to have really crisp examples of like what the impact is, and like just hands down, I was wrong. It's significant using standard out versus using a logger. Mostly how they batch up the things that get pushed to standard out. I don't know all the intricacies behind the scenes, but like it was very clear. We did it with Python, we did it with Bash, we did it with Go. Like hands down, using a logger was better and using log levels than than just printing the standard out. So I'm a Bash fan. I don't use Z Shell. The fact that Z Shell is not zero indexed drives me up the wall, but that's all right. Sorry. I know Lua and MATLAB and Z Shell share that in common, a few other languages. I just am a traditionalist. Like everything else, C, Go, everything is in zero indexed. Why, oh why, Z Shell did you make it one indexed? So yeah, Z Shell plugins, was it oh my Z Shell was really great. Bash has an equivalent one though, and so I'm a fan. Yeah, you set it that way, but when people run it, that's usually set by default once. Everything you give to them fails in really weird ways. So we're a Bash only shop. We require any script to be written in Bash 4.0 or above. So that way you can use like associative arrays, hash tables pretty much, and things like that. Some of the features, the uppercase, the lowercase features. There's a lot of stuff that comes in Bash 4.0 that's super nice. But yeah, we require everything. We also package up Bash with every script. So when we deploy, we have dependency enclosures. I don't know if you folks are familiar with dependency enclosures, but basically you're locking things, you're pinning things in place and saying this is this dependency at this version is what's being deployed together. That way you know how things are going to react and behave when they deploy to a system. And so we require when you're developing to pin the version of your Bash. You cannot use what's on the system. You have to use what's brought with you. Ditto for everything else. Still write everything in Bash and make it POSIX compliant. Okay, we don't make it POSIX compliant. We sometimes you do, but most of the time, again, because we push the whole thing out, most of the scripts are not in a state where they're going to be copy pasted somewhere. If they are going to be in a copy pastable format, I agree. We make it POSIX compliant just so that the lowest common denominator is handled for any sort of distro or OS we're using. But otherwise, we rely heavily upon the fact that it's going to be run in its own environment, its own ecosystem. All right, what else we have? Any other questions I can answer? Yeah, 16 seconds, significantly longer than the logging. Yeah. I know we're over time, so we can also call it here. But if you folks have questions, I'm more than willing to share them. Yeah, no worries. Thanks, folks. Again, hit me up in the Discord, especially if you have follow-up questions that are specific. We appreciate you folks kind of hanging with me, joining. What resources, if any, are free that you use to learn Go? Okay, this one is easy, hands down. I have a lot of Go resources. I've got a book behind me I'll share in a second, which is really good. Yeah, this is it. If you want to learn Go, this combo, and I would say choose something like, was it Code Wars or, one of those sort of tools, right? Combine those two, I would say that's going to make you at least proficient enough that you can read Go, you can make some updates and changes, and I would say confident enough like you could easily put it on your resume, hands down. So that would be my recommendation, because they cover things like structures, because Go's not really traditionally object oriented. It has some features of it, but it's missing some things like inheritance. So Go doesn't have classes, it has structures, it does have methods, but like this tour is going to walk you through that. It's got a sandbox right beside it, so you can literally fuck around with it and see how that stuff works. And then if you combine that with trying to do a task, right, then I think you'll have a good gist of how Go works in conjunction as to like another language. So if you use Python, right, you would get a sense for like how things are different. Go is very, very opinionated on lots of stuff, and so like you can't just randomly import a package and not use it. You have to use it. Likewise, you You can't just declare a variable and not use it. So those sort of things could take a little bit of time. Going through this little link I just gave you will give you all that experience. You'll get a quick overview. You have to check basically the exit status or return from all commands, for most commands, I would say. And so getting the habit to learn those things is just, kind of key. And I'm by far not a Go expert. I'm just a Go enthusiast. I really enjoy it. And a lot of teams at where I work utilize it. All right. Any last questions? Otherwise, we'll control by its typing.
Hey, no question here, but I was gonna say, will you tell them the story? I'm actually putting this quote out in general, but will you tell them the story about well, not the whole thing if you don't want, but just the end of when you took Phoebe down to the dog trainer? What they told you as you left there?
Oh yeah, that was our German Shepherd was doing doggy daycare. She had an incident where she bit the trainer. This is or bit the person that was walking with her. They were taking her inside. She had a chest harness leash. I don't know if you folks have seen those. They're very short. They have two attachments. They're meant to kind of control the dog, so there's not a lot of place to go. And they slammed the door on her back leg. They did not give us video, so this is all through their word. And yeah, so she bit someone, so they ejected her immediately from there. They were very sad and upset. They really liked Phoebe. That sucked for us because this is the first time she'd ever had a negative interaction with anyone. And so we did some really aggressive training down in Oregon for 6 weeks, maybe 9 weeks, where they worked with her and worked with us. Out of that training, they basically said, look, if a dog can't escape and you put the dog in pain, they're going to be reactive. We don't fault the dog. We have not seen anything that would lead us to believe after 9 weeks of working with her that she's not safe to be around. But she does have anxiety issues, and these are some ways to help manage the anxiety. At the very end, we were working through all these different training methodologies and stuff. And one of them, you can do treats. You have positive reinforcement. You also have this sort of negative reinforcement. So we use things like collar, a prong, thing like that. And you want to combine those two, so it's not just one or the other. But one of the big things that she said as we were walking away that I really appreciated and I've taken to heart was that if nothing changes, nothing changes. And basically that is, if you go back and you fall into your old habits, your old rut, then nothing's going to change. And you should not expect anything to change. So in order to make change, you have to do a dedicated, thoughtful effort to change your behavior. And that is extremely hard. I forgot who was talking about homeostasis, which talk that was, but this is humans. We like to fall into the same patterns. This is human nature for most folks. And it makes it really difficult for us to adjust our behavior because we tend to fall back on bad behaviors. So Unix philosophy, yeah. So it's composition. This is where if I had something that I disagreed strongly with at work and probably have gotten in a few arguments, it's around composition. So the Unix philosophy is each thing is its own single thing, and it does whatever it does really well, right? And so pipes is this great concept, that was it Richards, Ken? Was it Rob Pike, or did Rob Pike do it? Whatever, Kernighan. It's all the old school folks. They built all these tools and things like awk and stuff with that in mind, that you would develop these tools and stuff, and you would not try to have super complex tools that do everything. You'd build a tool, you would pull them together, and composition allows it to solve whatever you need and to be very variable. And that's sort of the Unix philosophy. And that's very important when you're developing systems, is to keep that in mind, that sort of composition, not to get into a state, we say monolithic is bad. It's not bad. But there are issues with it. And one of the issues is things start doing too many other things, and it becomes very hard to refactor or work or fix things. So composition, that Unix philosophy of, each function doesn't have to do, you don't have to do Uncle Bob style if everything only does one thing. I think that's ridiculous, but you do have to start thinking about what is the domain of whatever I'm working on, and does it make sense to start adding and tacking on other stuff. So the Unix philosophy should should influence your designs, your documents, your scripts, your code, how you do things, and you should try to think about it that way. And this is counter because a lot of times when teams get really excited about something, they want to start tacking on more things and like, well, we can make this do everything. So contingent authorization is a really big thing at where I work. We have a bunch of tooling and stuff around it, and a lot of that tooling starts getting into this sort of Uber category. It's very difficult, very fragile because it tries to do too many things, right? And there's some alternative tooling that for contingent auth that does that's more of the Unix philosophy, and that's what I'm a fan of. You should do one thing and do it really well, and that should be your domain. And if you don't care about it, then don't be trying to write it. But if it is your core sort of logical domain, you should really know it and spend time to learn it and then write it, and not just use random libraries or other stuff or tie it to other things. It should be really on its own and be able to stand on its own. So that's the sort of Unix philosophy in a nutshell. And for me, this makes sense. And I think it's Treasure, you said like alternative to what. I'm with you, but other folks feel very strongly that like, well, if it's already doing this, why don't we, tag on auditing to this contingent auth as well? Because it's already dealing with this. Like you can see the mental wheels for these folks that want to have greater scope or want to have their tool be used more or be more accessible. You can see how it can start sliding that direction. Yeah, so. Yeah, Ken, thank you. Kernigan for awk. That's right. Brian Kernigan, isn't he like the K in awk? I forget. I'm sorry.
I was just making a joke about tacking on extra functionality to awk, so like awk++. It does email now.
What?
No, I'm kidding.
Don't stress me out. But yeah, so it's very tempting because you build something, people start using it. I've done this before, and rather than stopping there and saying it's done its thing, I don't want to tack on extra stuff that's going to make it fragile or difficult or like tied to it, especially if it's going to create state. King Bun said it. It's evil. State is evil. That's how it happens. That's really how it happens. Is you just get really excited. You want to build more, do more, and it's tough to say this doesn't make sense to add to this. It should be its own separate service, like its own thing. And if we want to tie into it, it should have an integration or interface that's really defined, clearly defined, and easily accessible that I will then tie into. But I should not just try to pull it into what I'm working on because it happens to sort of cross lanes or because I think we're an awesome dev team and we can tackle it too. And that shit happens, especially at big companies. People got promos to do. So gotta write that promo. Gotta make yourself available. So any other last questions I can answer before we call it? And I guess my question to you folks is, after the talk on systems engineering, would you consider a job in systems engineering, or would you say, hell no, this is not for me? I would prefer to be an SDE or a DevOps or SRE and call it a day. Yeah, we are hiring. Yeah. All right. Well, with that being said, thank you folks so much for tuning in. It's good to talk to you and just hear other perspectives and stuff. And I really enjoyed the conference. Everyone that's doing it, I learned a lot of stuff. It's definitely not in my bailiwick. It's outside of my wheelhouse, but it was a blast. And if anyone does record their lectures, I think I need to go over a few of those, especially the data analytics one. I was trying to keep track and was kind of losing it. But thank you folks so much. And like I said, I'll be in Discord. We can chat some other time. I'll try and pick up Twitch streaming when it makes logical sense. And hopefully I'll see you folks around, or at least hear about your attempts, or some of you folks joining systems engineering. Take it easy.
Good job. Take care.